So I'm presenting today, I would say, yet another REST framework, and I will try to convince you that there's something different in there. It's called erOCCI. So if you have, if you had a look at a documentation for a REST API of any kind of services, for instance, one of OpenStack services. So if you had a look at this kind of documentation, you will find that for a REST API, there's a lot of different things to document. You have, of course, the data that it is exchanged between the client and the server. There is the format of the data, the type of the data, but also you need to expose to the user, which needs this documentation, information for filtering the information, sorting the information, paginating when you have a large amount of data to expose. There is also documentation about the authentication, the authorization mechanism, which can be token-based, header-based, certificates, or something else. And finally, at the end, you get into the interesting stuff, which is what the API is exposing, what is it dealing with, means the really application. In the case of Neutron, for instance, okay, it's not really clear, but it was Neutron just as an example. We deal with networks, we deal with IP address, we deal with net masks, and so on. And this is the important information in the REST API. One could say that for the data format, why having a documentation of several pages when you could use a schema, a JSON schema, XML schema? Sometimes it's used, sometimes not, and sometimes you have to explicit them into the documentation. For the protocol to access the data, about the filtering, the sorting, the pagination, authentication, and return codes of HTTP, the semantic you give to the return codes. There is no rule, a standard rule for all REST APIs. So, kind of each different services use their own rules. And at the end, to describe the application semantics, the really application semantic, it is difficult to imagine that you have a standard for that. But a meta model approach could help in exposing to the user what is the relation between the different data that you're exposing to the users, the relation or the type of the structure, the name of the structure, or they inherited, or they in what they are related one to another. For instance, network interface, in what it is related to the network information and such. So basically, from a user point of view, in the documentation of a REST API, I find a lot of information which are not really related to the application itself. So I will speak a little bit about the standard. And usually when someone speaks about the standard, we imagine big books, large documentation, something which takes a long time to discuss and to agree on. But I will show you that from my point of view, a standard must be simple and must help the user, must help the developer, and that's why I have based my work on a standard. So for REST, for me, what could be a good standard? A standard is not a catalog of schema. Like in the domain infrastructure, we are speaking about in these OpenStack conferences. You have the CME standard, for instance, which is a big amount of schema which defines what is a network, how to call a CPU, how to call memory, how to call an operating system, how to define this version of an operating system, and such and such. For me, this is not, from a developer point of view or from a user point of view, this is too complex. So this is not interesting. it is constraining because if I call the number of if I want in my API to expose the number of cores in a virtual machine, I called it cores in my API, and I want to converge to a standard, and maybe I will have to name it with another name. So I will have to change something, and it is constraining, and it's not interesting for a developer or for a user. Plus, a standard must be implementable, must be implemented. So it must be implementable. I don't know if the word exists in English, but I suppose you will understand. If it's too complex, there is no. You will never find two implementations which are compatible with each other. So a good standard, for me, should allow to concentrate only on the design of the application and just let the standard be implemented in a tool which do all the hard work behind, and the details which are not really the focus of my application. A standard should allow to get tools from the ecosystem and get and this tool to work out of the box. So at the end, a good standard should only allow to accelerate the development of an application and build a complete system, and not force the developer to change his habits or change his existing applications. With these criteria, it appears that there is a standard which is called the Open Cloud Computing Interface. It was launched by Sun by the time. Now it's developed in the frame of the Open Grid Forum. In the Open Grid Forum, there is a working group for this standard. And what is this standard about? The Open Cloud Computing Interface, or OCCI, let's call it OCCI. OCCI, it defines a typing mechanism for the data. So it is a standard for REST API, so it is resource-oriented. So we speak about resources. So a resource has a kind. The kind is the family, or the category, let's call it like this. What is a kind? A kind is a name, is a name associated with a list of attributes. For instance, a virtual machine is represented with a kind which is called compute, and it defines a set of attributes: the number of cores, the amount of RAM, or something like this. But this is just an example. OCCI give the tools to name it and to give a type to these attributes. These attributes can also have a default value, mutability properties, and so on, which is what you need when you define attributes. And you can also associate actions with to a kind. An action is an operation which is a little bit more complex than just changing the value of an attribute. But basically, this is changing attributes. And kinds are inheritable. So there is kind of a relation. You can define relations between the kinds. OCCI is extensible because it is not supposed just to define a catalog of schema, a catalog of resources. OCCI gives the mechanism to name the resources, the kinds, but and so it must be extensible. It is extensible in several ways. There is the resources, so they have a kind, but they can also be associated with the mixin, which is something that you plug onto the resource, and you add attributes once the resource has been created. For instance, you have a resource which represents a network interface, and you say that this network interface is an IP network interface. So you add the IP address, the net mask, and that kind of information. On an OCCI API, the user can also create its own mixin. without attributes or without actions. It is just used to tag the resources. For instance, the user can create my project one mixin and associate it with any resources, which can be a virtual machine, a network, or anything else, which will represent a tag put on these given resources. In OCCI, you can express relations between the resources. So you can express relations between kinds, you can inherit, but you can also express the relation between the resources themselves. For that, there is something which is called the links. And the link is just a resource, traditional resource, with two additional attributes, mandatory, the source and the target. The meaning is kind of simple. So it is used to make the link between two resources. To express the relation between resources, you have also the notion of collection, which is a notion which comes from the REST, the REST architecture. So bounded collection is the list of resources which belongs to the same kind or the same mixin. So even if your resources are not on the same path, there is a path in the API, which gives you all, for instance, all the resources which belongs to the compute kind. There is also the unbounded collections, which is like on a file system, when you say, I want all the resources with which path start with that name. Okay. And finally, the OCCI is self-described. So if you expose an OCCI service, you don't have to tell the user where to find the collection of, for instance, virtual machines, the collection of networks. No, the OCCI service has a special URL dash, which gives you the list of supported kinds and mixins and the associated collection path. Yeah, and finally, OCCI. So to allow all this, OCCI is based on a meta model, which is as generic as possible, which is resource-oriented. So it fits really well with the REST architecture. And you have on the diagram all the notions I have explained briefly before. And what this meta model, why this meta model, and what it allows? It allows to do model checking. It allows you in a certain way to automatize a lot of the implementation of a REST API, and this is mainly the main interest. It is independent from the rendering, which means that once you have designed your application in terms of kinds, mixin, and so on, it can be rendered as a JSON, as XML, or you can invent any rendering, but the meaning, the semantic will be the same, and your design will be the same. It is independent from the transport. Of course, it has been first implemented in HTTP, but in erOCCI we have implemented it in XMPP, in DBUS, and of course the schema, the design of your application remains the same, and just the transport change. So we are not the first one, not the only one to have implemented the OCCI, an OCCI API. It exists already some frameworks like erOCCI in Ruby, but it has not been designed for genericity in mind. It has been designed to interact with different IaaS backend. Means that with the same OCCI API, you can address an OpenStack, you can address OpenNebula, you can address Azure, or so on and so on. But mainly focused on IaaS. OCCI for Java, but it's not maintained. There's also some Python implementation, but once again, it's not nor generic nor really maintained. There are some tools of various sort. Do you speak OCCI, which is a suite of tests to test the compliance of your implementation against the OCCI standard. There are some monitoring tools developed by Intel. I don't know the name because the project is really young, but it is good to see that I developed an application with erOCCI, which complies to the OCCI API, and I just made someone who had developed this monitoring tool, and it is able to communicate and to monitor the erOCCI instance because we speak the same standard. There are also a lot of specific implementation. I mean, implementation of specific API, mainly IaaS, so virtual machines, networks, and storage. The biggest one is CompatibleOne, which has implemented a lot of extensions to deal with the brokering of cloud services. So it can address IaaS, but also some part of PaaS, and be able to select for the user the best provider for a given request. POCNI, which is dedicated to networking for software-defined networks, and of course the major cloud systems like OpenStack, OpenNebula have an implementation of OCCI for accessing part of the API. Okay, but as I said, most of this implementation are dedicated to a specific usage, and the most important is that the description, the design of your application must be done in the language of the implementation. Means that if you want to use OCCI for designing your application, you have to code your kinds, your mixin, you have to describe them with the Ruby language, because these kinds of mixin are basically Ruby classes inheriting the base OCCI classes. So the goal of the erOCCI framework was first the genericity, a set of tools to design any kind of REST API compliant with OCCI, with also the objective of coding less and letting more the implementation to do the hard work behind. erOCCI wanted to be small, tested, and reliable as a core foundation for designing REST APIs. So something that we can be sure that we can take, it works. Easy to deploy. We don't want to have the need for a web front end, for instance, or deploying an external database, which can be the case for other frameworks. It needs to be scalable because erOCCI was designed for a project which wants to embed these kind of APIs in connected objects. So it needs to be able to run on a Raspberry Pi, for instance, and it works. And be able to scale out to millions of users in case of a REST API for a big service. And it needs to be extensible because we don't know if the data source came from a database or from an external API or for something else. So we want it to be extensible as much as possible. So basically, this is the architecture of the whole framework, and I will go into details later. So basically, there is the OCCI store, which is the core of the framework, which is kind of a virtual file system. It dispatches the request to the resources to the backends. It deals with the authentication through plugins. So you can have different kind of authentication, basically HT-password file-based authentication, or XMPP authentication. And then it dispatches the operation to backends, which can be plugged at runtime on any path of the endpoint. most of backends have been written in Erlang because the erOCCI is in Erlang, and the rules for accessing parts of the API are dealt with the access control list. So basically, if you just want to store your resources in a database, you don't have any code to write. You just describe the categories, you describe the access control, you choose the backend. Yeah, there is a database integrated into Erlang, distributed, fault tolerant, so it can't deal with a large amount of data, but it does a job for medium-sized services. And at the end, of course, all these resources can be exposed through different listeners. You can plug different listeners at the same time. It means that on a single instance, you can expose the API through HTTP, through XMPP at the same time, or any other one that you have written. HTTP, HTTPS, of course. Okay, so about the genericity. So no OCCI extension is hard-coded. There is no code about the compute, the description of a computer, of a virtual machine, of a network, of a storage. Only the meta model is coded into the framework. Everything is pluggable, as I told. The authentication mechanism, the transport, the data sources are pluggable at runtime. And you can compose services by plugging data sources at runtime. Means that if you have a specialized backend which deals with, for instance, communicating with OpenStack, you have another backend which deals with the management of your users because it connects to LDAP servers. You can plug them in any way you want, and you can compose the application just by plugging the backends when you start the erOCCI framework. Less code, more design. The resource, the categories of the application are described thanks to an XML schema, an XML file, and the authorization are based on SCL, so you don't have to code for describing the resources or describing the authorizations. It is small. It's difficult to evaluate the size because there's a lot of different components that you can enable or not, but basically it's around between 10 or 15K lines of Erlang. It is tested. It is also, unfortunately, we don't use yet the infrastructure of OW2 for that, Jenkins, but it is, the migration is an ongoing process, and we today use Travis for that. It is reliable. We use as much as possible small components which has already been tested in the industry, like for instance the web server. It's Cowboy. It's an Erlang web server which has been used which is in LeoFS, for instance, which is deployed by Rakuten on big web services, which is used in Mongoose IM, which is an instant messaging server, which is used, for instance, by WhatsApp. Reliable because we use the Erlang OTP platform, which provides, I would say, out-of-the-box fault tolerance. Of course, if you want total fault tolerance, there's a little code to do, but just with the basics, we have a good level of fault tolerance with, for instance, process supervision and some other mechanisms that are provided by the Erlang platform. It's easy to deploy. We use the OTP platform. It has been done 30 years ago or 20 years ago maybe by Ericsson for embedded appliances. So there's all the tools to deploy an Erlang application, package it, and just copy it on a device. So now if you want to deploy it on a server, it's just okay, as simple as a jar file that you deploy on a Java application server, for instance. But you can try it, and you will see that it's easy to deploy. It's scalable. We have made run it on Raspberry Pi and link some tens of requests per second, but we need to be more precise when I will set up load injection tools more intensively. And it can scale. The same instance can scale on different on several machines, thanks to the Erlang platform, without any technology like Docker or like a virtual machine. And so no, just the Erlang platform runs on a cluster seamlessly. It's extensible thanks to the different APIs to plug data sources, authentication. I've already talked about this. And for those who don't like Erlang, because they are, and it's not a really common language. So there is now a DBUS API for writing backends. It's experimental. The API is evolving, and the DBUS API is not always evolving at the same speed. So sometimes it can be broken. But we have basically an example of a DBUS backend with some tens of lines of Python code. And just to give you an idea on what it can be used for, because we are here in the OpenStack Summit, but the REST API are used at a broader level than just the IaaS, the infrastructure as a service. So for instance, writing a blog with a REST API and a JavaScript front-end, a full JavaScript front-end like Angular or Backbone, you can do it with erOCCI, just writing an XML file, basically. You describe the categories of, you design your application. Your application will have blog entries, users, and contributions, which links users to blog entries, and that's all. And you start erOCCI with this XML schema, and the API is exposed. You just have to, you can just choose the storage backend that you want. We have a backend database which already exists. You choose a transport. Naturally, it will be HTTP, but if you want to make a blog exposed in XMPP, why not? You can define the ACL, and that's all. There's no code in there. OCCI was mainly designed at the beginning to adapt API in the IaaS world, meaning being able to address OpenStack, OpenNebula, Azure, or Eucalyptus the same way. So if you want to implement that kind of application with erOCCI, you will have to write a backend thanks to the backend API, either in Erlang, either in DBUS. In any case, the backends only implements the CRUD operation: create, retrieve, update, delete, with some less than 10 data structures, and then it's done. And then after that, you can choose the transport independently from the backend. You can choose the transport, you can choose the authentication mechanism, and so on and so on. And all the scalability, the supervision, the different protocols are provided as is by the erOCCI. The last use case would be, for instance, a protocol adapter. This is a use case we have already developed for a customer, where data was arriving through a specific UDP protocol, UDP-based protocol, and it wanted to expose through a REST API. We use the OCCI Store API like a storage mechanism, and then we plug the HTTP listener on top of that, and that's done. So the roadmap is there's these dots here because there's a lot of things in mind. For the authentication, as of today, we have two kinds of authentication, but of course, certificate or auth authentication or something we really need soon. Improve the testing, because we have set up the functional testing and the unit testing, but this is a process which is never finished. The more tests we have, the more the framework will be. The OCCI Store, as I presented, is really the core, and it's the core of the framework, and is really stressed. So having some optimization in there, and integrate in the OCCI Store the authentication mechanism, the pagination, because as of today, you have to deal for the pagination, for instance, you have to deal a little bit in the backends. A little bit is handled by the OCCI Store, but a little bit by the backend. So the idea would be that the OCCI Store would deal entirely with the pagination, and the backend just to provide the data. The XMPP transport, it works today, but there's a lot of mechanism in XMPP which could be really interesting for monitoring, for instance, supervision or monitoring, and for instance, implementing the pub/sub mechanism, which allow notifications to the user when a resource has changed. I want to be notified. This is something that we want to implement. And of course, new storage backends, because the Mnesia backend, just without going into detail, in one Mnesia backend, you are limited to 4 gigabytes of data. So for a lot of applications, this is not a limit, but for other applications, it can be. So we have started a RAIAC backend, which is a NoSQL database, and of course, having a backend for regular SQL database, which would be a good thing also. So this is an open roadmap. Anybody which try erOCCI and have an idea is welcome to contribute. And before stopping, around this work, we have designed a consortium. There's an existing ecosystem, mainly around the OCCIware initiative, which may be a real project in a few times. But as of today, it's already a consortium of industrial partners, academic partners, standardization groups also, which are interested in working together to complete the OCCI ecosystem, the OCCI let's say, base tools ecosystem with theoretical tools to prove that the meta model of OCCI is really compliant with the REST architecture, can fit for all the needs that we want to cover. There's also partners which are interested in designing tools for helping engineers to design application as a OCCI with the OCCI meta model, and of course complete the erOCCI erOCCI runtime to implement these applications, or design other runtimes to be able to deal with some other case where erlang is not well suited, or for any reason erOCCI cannot is not the best solution. And this consortium has been designed also around use cases, which tries to cover every domains where REST API are used. So not only infrastructure as a service, but also platform as a service, software as a service, Internet of Things, which is also a big consumer of REST APIs, big data, data analytics, and so on. Every kind of RESTful services. So here's a list of some resources to have information on erOCCI. So the website is hosted on OW2, but the migration from GitHub to OW2 is not completely done yet. The source code can be found on the GitHub. Continuous integration on Travis. There are mailing lists if you want to communicate with the project.